Hello there. Now we are going to be discussing about the distribution load. The distributed load is going to be one of the important aspect in engineering field. So far we have seen the distributed loads, what is the distributed loads and its nature we have discussed. And that is that the distributed loads maybe chances are there to act along the length of the any member or the area of the member or volume of the member that we have discussed. Now we can see if the distributed load is going to be acting on a beam, then how we can convert and how we can simplify for the mathematical analysis purpose. As we know that if the distributed load is going to be exactly existed its own nature, but it's very difficult to do the further analysis of engineering analysis. So then now we can see that the same how we are going to be converting into a simplified diagram for that part. Now we can see the heading is that the distribution load on a beam. As we know that the beams are going to be very widely using for our engineering applications to carry the load, and the type of the load is going to be the shear forces or shear loads or the bending moments. It's going to be widely it is going to be carrying. So there we can see here the distributed load on a beam. So then we are going to be considering if the distribution load is going to be acting on a beam, so then what will happen there? So then in this case what will happen there, the diagram I'm going to be show pictorially that one end I'm going to be say the A, another end is the B. So that's AB is going to be the beam and it is going to be mounted on a roller as well as the triangle support over here. So then what will happen? So then these supports are going to be arresting the degrees of freedom. That means reducing the free movements of this beam in the downward direction or maybe in the horizontal direction, whatever it may be. So then what will happen? Then there's going to be a distributed load is going to be acting. That's I'm going to be considering over the length of the beam. And then I'm going to be say this diagram is going to be called load diagram. What is this one? This is going to be the load diagram we are going to be calling. So then how we are going to be simplify this the load diagram or the distributed load on a beam. So then what will happen? For the simplification purpose, I am going to be converting into a series of parallel lines I am going to be taking. So then in this case, the same diagram I am going to be taking over here. So this is going to be the beam A as well as the B, and this is going to be supported on the roller and on the triangle edge it is going to be representing. So then the same configuration I have taken over here, but rather than taking the material in this one, that I'm going to be representing with the arrowheads. It means that is the parallel lines I have taken over here. That means the parallel arrowheads I have taken. It means that the arrowhead of this is going to be representing that the load is going to be exactly coming on the beam over here. So it is representing the large number of parallel loads are going to be acting on the finite element area it is going to be representing. But the cumulatively it is going to be representing the distribution load here. So then what will happen? Further simplification I am going to be doing over here by taking this part. So what is that one? The same AB is going to be the beam we do have taken. So this is going to be your beam A and the beam B roller supports I have taken as it is. So then in this case what will happen? For the simplification purpose I am going to be taking the series of the parallel arrowheads lines I am going to be taking over here. So it is going to be representing the distribution load over the beam. But these point loads are going to be representing, it is going to be acting at the infinite area, it is going to be acting over there. But overall cumulatively it is going to be representing the same. Or if this is going to be representing the uniformly distributed load. That means UDL we are going to be say. UDL means uniformly distributed load. Or if you don't want to representing the uniform distributed load, that also we can representing in terms of uniformly varying load also we can show B. This is going to be as it is I have taken. So then what will happen in this case? So I am going to be taking this way. This is going to be uniformly varying load I am going to be representing. So can you see the series of parallel lines, the parallel point lines we do have taken, and that's I'm going to be representing over here. So this way we are going to be representing the distributed load on a beam into the noun point loads. So that what will happen? The mathematical or engineering analysis is going to be very easy. So in this one, how the load is going to be representing? That means the load per unit. So that's I'm going to be representing load per unit length. This way it is going to be representing, that is the Newton per meter, it is going to be representing. So mostly we are going to be converting unknown terminologies into the known parameters. In this case, there we can see here the distributed load over here, and that's we converted into the uniformly distributed load or uniformly varying load we do have converted. And then what will happen in this case, whatever the effect is going to be generated from this uniformly distributed load on AB at the case 1 and the case 3 and the case 4 also is going to be generating the same kind of the effect without changing of this one. See why we changed from this position to this position. The reason is that we did the simplification for the engineering analysis purpose. We have done that part. So the outcome is that from the discussion we are able to understand then how the distributed load over the length of the beam that we have seen, that's going to be, and how to simplify the distributed load in terms of the point loads, how we have converted, that we have discussed. So this way we are going to be discussing about the distribution of load on a beam. So by hoping that you are able to understand the distribution of a load on a beam, and I would like to say that thank you for supporting me.